Hello YouTube, RJ. Hey, I've got something on the bench to take a look at. Found another little test device on eBay. You know my saying, gotta stay off of eBay. Found a interesting little test device, or lab device, lab equipment device, that was not very much. I paid $4.99 for this, plus a couple dollars shipping. It's something I've never owned. Could have used a couple times over the years, but not much. But it was so inexpensive and such an odd device, I just had to pick it up. This is a RTD simulator. It's a resistive temperature device simulator. And this is what it is. Let's get it out of the box and take a look at it. It's got 3 terminals here, 2 marked RTD, and then one that's off by itself that looks like a common. And then back here it's got 4 plugs. It is a model CL6030 RTD simulator. And I know very little about it. I did a little searching on the internet. I know what an RTD simulator is and what it does, but this particular one, looking for a manual or whatever, I've not been able to find anything. I saw a number of these online and they were wanting like $199 for them. This one was $4.99, and the seller said, you know, it was my dad's. He took good care of stuff. I think it's probably in good shape. Don't know. So it piqued my interest. Anyway, you've got a toggle here for measure and output. For 0 and span, it says fine 0 to 100 ohms and coarse 0 to 500 ohms. And over here, as I said, it says RTD right here on these 2 terminals. My understanding, well, let's put it this way. I'll tell you what I know about it, then I'll tell you what I think about it. I know that the purpose of these was to generate a very accurate resistance that was very temperature independent. The coefficient of temperature very low. In other words, you want to set a resistance here, no matter what happens with the temperature, you don't want it to drift. You wanted it to be able to be set very precisely and stay there. And the purpose for that was when you were developing equipment that used these resistive temperature devices to read temperatures, you needed a way to design and calibrate your equipment and test your circuitry and make sure it's linear and it works correctly and it's accurate. And so there was these type of devices, and these went up in levels and more sophisticated. They made ones that were like handheld signal generators. Basically, you plug in a temperature and it would generate the right resistance. You could tell what type of thermocouple, what type of resistive temperature device you were using. You told it then what temperature you wanted to simulate, and boom, it put out the right signal for right resistance. This was a more simple. Now, even though they were simple, they weren't cheap. These things were over $1,000 in their day. So I'm assuming that the items here must be very precise to be able to hold the kind of specs that they met. So you've got the 2 main potentiometers. Let me tell you a little about these. When you turn them, they feel very different than most pots. They have detents, very fine little detents on them. You won't be able to hear or probably tell, but I can turn this precisely an amount each time on both of these. So they were detented pots. They didn't have big clunky pots or clunky detents. They're very fine little detents, and they're multi-turn. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm expecting 10. Almost 10. So I'm going to say they're 10 turn pots. These little screws you see here are going to be also pots. They're going to be trimmer pots. They're multi-turn, very precise. And these were calibrating pots, is my understanding. Now, you hooked your piece of equipment to here, and this was your RTD right here. This is where you simulated this. The outputs here simulated you having a temperature sensor right there. Based on what you set here, your equipment would recognize that resistant as a certain temperature. Now the 4 prongs back here are interesting. And my guess on these is that these were designed to plug into precision voltage resistance equipment, and you probably switched this to measure, plug this in, and you calibrated it, would be my guess. Once you've done calibrating, you pulled it off, and now you were ready to use this. It was in calibration, and you used this from that point on. That's my guess. So I thought first thing we'd do is, now that we've talked about it and looked at it a little bit, is tear it apart and take a look inside and see what we find. So let's open this thing up. I did notice the screws are a little rusty. Nothing else on it looks that way, but it's must have got a little moisture in on these steel screws. Everything else on them is plated, and you know, it's got looks like some gold plating and such. Got a little tarnish back here, but no corrosion per se. So let's open it up and see what we see. Curious to see what we find when we get this. Not your everyday kind of piece of equipment. Yeah, those could use a cleaning of some kind. It comes apart pretty easy. And let's see what we have in here. Well, you definitely got some gold-plated connectors down here, your post. And it looks like that 4-pin I thought might be a 4-wire connection for precision resistance, but it's not, it's 2. But of course, I guess we're coming out as 2. I see these 2 posts are tied together, so that's a common post. Maybe this is where you connect your common from your equipment. I imagine that's what it is. That brings these, that brings this to common with your equipment, I imagine. And then your probe, this is your input for your probes. So all that's down in here is the connection to these 2 posts here, and then your post here, banana jack post here. And these are smaller, not full-size banana jacks. So other than that, everything we see is right here. Let me see how I can get this to where we might be able to see. What's this label saying here? Can we get a view of that decent? It says RTS 1050-958 CL6030, job number 271175, revision B, test quality control by number 106, made in USA. So there you go. Rochester Instrument Systems or something like that made it. So it was a USA made piece of equipment. And we can see in here it's really not a lot to it. Looks like the 2 switches and then a trimmer pot. I figured that's what these were. These look pretty fancy little trimmers here. They're Bourne's trim pots, multi-turn trim pots. And then you've got some, here's a 100K potentiometer. See if I can get a shot of that, a good shot of that maybe. Let's see if we can maybe get up here where y'all can see what I'm seeing. Looks like model 534 resistor 100R plus or minus 5%. Well, that's not that precision. Oh well, linearity though is plus or minus 0.25%. So they're extremely linear. Spectral reliance precision potentiometer. Okay. What's this one over here? This is 100 ohm, and this one is a, trying to see here, it looks the same, 100R. I figured they would be different. So this switches, I don't know, the way that's wired in there, it doesn't look like it's switching the inputs. Oh no, the inputs are up here. Okay, so the inputs are definitely being switched by the measure and output. So as I said, yeah, exactly what's happening. This or this you're connecting to, depending on which way that switch is. This zero or span, okay, it looks like these trimmer pots are set up, and what they're doing is they're calibrating the zero and the span of these pots. And what happens is, depending on which one of these, when you're measuring, you put it in a different position to adjust to get your zero and to get your span. So that's interesting. Anyway, neat little piece of equipment. I guarantee you these pots probably cost way more than the $5 I paid. So don't feel like I got rooked. Just was a little interested in it. Wanted to see what I could see on it. And you know, it's just interesting to have this kind of stuff. I may work on something where I'm wanting to use thermocouplers or something, and it'd be nice to have a way to simulate different temperatures stably. So let me throw this back together real quick, and we'll hook up a meter to it, and we'll see how it acts. Be right back. All right, we're back. Here's what I've done. I've got the one camera set up on the LCR meter so we can see accurate resistance. So I'm going to play around with this a little bit and see what we get. I've got it connected up to the output. I'm on measurement. I'm getting overload. So obviously we're not connected to these when we're on here, but I expect when I go to output it'll change. Oh yeah. See what we get. Looks like we're getting just over 1,000 ohms. So what happens when we start turning knobs? Things change. I'm not seeing it change. Okay. What if I change this one? Oh, now we're going up. Just let it stabilize a second. Let's see where it ends up at. Let's say 167 roughly. Okay, let me turn it one click. Hardly a change if there is. Another click. Again, hardly a change. Maybe 0.0001 kilo ohms. Let's go up a couple. I mean, it looks like this thing, you have to turn number of clicks, it looks like, to move. Okay. I mean, it's hardly moving. Let me turn it a bunch. Oh man, this thing has such a fine resistive control. Look how little it's changing. Let's go down all the way back down. Okay, and let's see. I'm gonna kind of take my hands off of it, and it's stabling out 1.08. Let's call it about 8.6. Let's say. Okay, so I'm gonna go 10 turns up. 1, 2. I'm sorry. 10 clicks, 10 detents. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's all the difference. Let's go up 10 more. 1, 2, 3, 4, 5, 8, 9, 10. Boy, that's some pretty fine adjustment. I mean, that's 10 detents to get 10884. What are we gonna call this? 883. Okay, it's 883 to 8893 on 10 clicks. So this goes up 0.01 ohms per detent of that wheel. Now, I assume that's the fine, but I don't see this knob doing anything. So I wonder if this switch, when you're not in the measure, switches between your potentiometer changes. That don't make sense. But why would this knob not change the resistance at all? Let's turn it all the way back down. I don't know. Anybody out there knows about this device, owned one, worked with one, has a manual of one, finds it on the internet, do me a favor, get in the comments and just tell me what I don't know about this thing. Fill us in on it. Let's flip to 0 and see if I go to 0, I'm still basically the same resistance. Does this change anything now? Oh wait, no I'm not. It just jumped, that's updated. now I'm wanting to see changes. Let's put this, let's change the speed to fast where it's updating quick. Okay, 1.0568. Yes, it's going up when I'm switched over here, but it's going up very little. I mean, I think it's the same 10 detenths to 0.1 ohms, but it's a different range. What's interesting is it says the fine range is 0 to 100 ohms and the coarse is 0 to 500 ohms, but that doesn't seem to be true because we're at 1K. Let me put this all the way back to 0. These both turned all the way down. I'm at 1.0492, almost 1.05. And what does this turn me up? Look at how little it moves. Okay, so all the way turned is 1.233 kilo ohms. Okay, we're back. I've got all these turned all the way counterclockwise. That's what I'm reading. I'm going to put it on 0. And I'm going to turn this one and see if anything happens. Yes, that's a calibration. I'm wondering if somebody messed around with this thing at some point to do something strange with it. Because it's supposed to start, the range is supposed to be 0 to 100 and 0 to 500 from what I saw, but how low can I get this thing? Can I get it to 0? I don't think so. Yeah, that's as low as I can get it. Just let it settle a second. See if this works when I turn it up now. Yep. Anybody can find out any data sheet on this thing, manual, whatever, calibration procedures. Drop me a comment, let me know. I'd love to find out. This thing is, it works the way I think for the most part. I just don't get why it's so far off from here to there and what the calibration procedures are. But you can see literally just how fine you can adjust this thing. It's a neat little device and definitely has some very fine control and resistance. And, you know, for $4.99, I like having it. Try to learn a little more about it. Nothing else at some point. These pots are worth more than that, I guarantee you. This could produce a very fine for a VFO or something if you wanted to really get a fine control adjustment for a voltage controlled VFO, man. These would be the pots to use for it. So thanks for tuning in. Hopefully you found something interesting in this video, even though it was just a review of this little device, the mystery box we'll call it. Hope to see you in the next video. Thanks for your time.